Okay, so what does FWIGI stand for? Find when given an equation. I'm going to abbreviate equation. Okay, this is the information we always have to kind of unlock out of that and translate from English into math. Okay, sometimes we're going to need to draw a picture. This is a perfect example because really I'm not even 100% sure what equation I'm going to use yet. Okay, so a kite is moving horizontally. Okay, so let's draw a little kite. No judgment on your artistic ability. And it's moving horizontally, left to right. That's implying that it's actually not moving vertically. Okay, it tells us the speed. Speed is another derivative word. Okay, per second, that also tells us that's going to be a rate. And we have an altitude of 30 meters. So let's draw that, and let's draw 30 meters. Altitude, like height. Okay, so then it asks us to cut off a little bit. Determine how fast the length of the string is increasing when the kite is 50 meters from the kite flyer. So where would the kite flyer be? Directly under the kite or off a little bit? Off a little bit, right? Okay, so here's the kite flyer right there. And if I connect these, I now have a right triangle. And so when they say the kite is 50 meters from the kite flyer, they are giving us the hypotenuse, not the base. The horizontal distance would be down here, but the distance between the kite and the kite flyer, 50 meters. So I have a 30 meter side, a 50 meter hypotenuse. Can anybody tell me what the other side would be then? 40. How'd you get that so fast? 3, 4, 5, Pythagorean triple. Okay, before we do our FWIGI, I'm going to go ahead and show you when we have right triangles. I'm always going to label the hypotenuse as C, and then A and B for the other sides. I'm going to use B for the base and A for the altitude. And it's just nice that A and B are in Pythagorean Theorem, and they stand for those two letters. So what is it asking us to find?
D something.
D something, because it's like how fast. D what? D A, B, or C? Yeah, the string of the kite, right? So dC over dt. And it even says increasing, which tells me my answer should be positive. And that's just good to know. It'll help me catch a mistake. All right, the when, we can list out what I've already drawn on the picture, or we can just draw a little arrow over it. Remember, this is just to organize our information. I'm not grading this part. This could get you partial credit, but I'm not great. This is not your answer. It's just a way to organize. So what's something in the problem I have not yet listed? What should I write next to the given?
A equals the speed.
Okay, so this 7 meters per second, that's a derivative of what? A, B, or C? And this word right here tells us. Horizontally, so dB. So dB over dt is 7. Now, should that be a positive or negative 7? Positive. Because remember, if the string is being let out, which is what they're telling us here, then it should also be getting further away from the kite flyer. Okay, and we've kind of hinted at this, but what is our equation going to be? Pythagorean theorem, a squared plus b squared equals c squared. And not all right triangle problems, but a lot of them are going to use this. It could be area, it could be trig, but Pythagorean theorem is a pretty common one. So let's go ahead and rewrite the formula up here. A squared plus b squared equals c squared. Let's take the derivative. Remember, we take the derivative with respect to time. So when I derive a squared, that's 2a, and then dA over dt. Since we're deriving with respect to time, anytime I get to a letter that's not t, which will be all of them, I got to go dA, d that letter, over dt. So the derivative of b squared would be very similar, 2b times dB over dt. I'm going to move this over just a little bit. equals 2c times dc over dt. Okay, after we take the derivative, we are ready to solve. Okay, plug in and solve. So let's do that. Actually, real quick, you see how each term has a 2? We could just divide everything by 2 and it's okay. If you don't want to do that, you don't have to. You get to use a calculator with this, so it's not like it really makes it that much easier, but it's something to note, and that's going to happen every time we do Pythagorean Theorem. So A was 30, just looking at the picture over here. Whoops, wrong way. A is 30. So I have 30. And ooh, dA over dt is not given. So this means I either need to do more work or they've implied it somewhere. So dA over dt would be like this thing is getting longer or shorter, smaller or bigger. What did I say about if the kite is moving horizontally, how is it not moving? Vertically. It doesn't say anything about vertical movement, so we're going to assume that dA over dt is 0. Okay, B was 40. dB over dt, that was the one that was given. C is 50. And dC over dt is what we're looking for. So you can either use the solve feature, or you can crunch the numbers, use your calculator, or not. This really isn't that tough to do without. But you're going to solve for dC, and you should be getting 5.6. We're going to call it meters per second, because that's the units on the others. Okay, so besides needing to draw a picture, this really isn't that much worse than what we did yesterday, I don't think. Without a picture, though, it gets pretty complicated. Okay, so I want you to read through question number 2 and decide what is the only thing. 2 is very similar to 1. There's just a tiny little difference. What is that difference? Yeah, the kite is also falling vertically with the speed of 5 meters per second. So in addition to the given, the dB over dt, that's still true. We're also given that dA over dt is negative 5 meters per second. Okay, everything else, if you read through the problem, is the same. All the sides are the same, all the other rates are the same. Just this is new. So we could go through, and if you wanted to practice, you could practice deriving Pythagorean Theorem again. We're going to get another shot at it in just a second. So the only thing it really does is this 0 right here needs to be replaced with negative 5. That's the only difference. So that's going to be 30 times negative 5 plus 40 times 7. So 50 times dC over dt. So go ahead and solve this out for your new dC over dt, and pay attention to whether your answer is positive or negative. That's going to tell us about, is the string being paid out or taken in. Okay, what are we all getting? Hopefully 2.6, which is a positive number, so that tells us that the string is being paid out because there's more string. It's longer. It's getting longer at this time. Okay? So that's a kite problem. It's a pretty standard, pretty popular problem. And so is the ladder problem. We talked a little bit about this earlier this week. Here we have a 13-foot ladder rests against the side of a house. When the base of the ladder is 5 feet from the base of the house, it's moving with a velocity of 3 feet per second away from the house. Determine how fast the top of the ladder is moving. Okay, we need to draw a picture. Okay, when you see these ladder problems, you need to just start with a right triangle. Where is the ladder in this picture? The hypotenuse. So we put the C there and we go ahead and put 13 feet right there. Remember, I'm always using B as the base, A as the altitude. You really can use any letters you want though. Okay, do they tell us any other sides of the right triangle? The base is 5 and that's part of our win. So if this is 5 feet, what's A? Yeah, that's another triple. If you didn't know that it was a triple, what could you do? Pythagorean theorem. You could always use Pythagorean theorem. Okay, so let's go ahead.
Will it always be 2 sides?
No, but if not, they'll give you an angle and you may have to use a little bit of trig. We won't worry about that just yet. Okay, so in this part A, it says determine how fast the top of the ladder is moving. Okay, so what they're asking is, so let me put some points here. They're telling us that the ladder is moving away, the base of the ladder is moving away from the house. So where's the top of the ladder moving? Up or down? Down. So we want to know how fast is the top of the ladder moving. We want to know the rate of change of A. And so I'm looking for dA over dt. And the fact that that ladder is moving down, that tells me that A is decreasing. So what do I know for sure about my answer then? Negative. Okay, if my answer ends up not being negative, I need to go back and check it. Okay, again with the win, you can rewrite it or just point to the picture. Whatever, this is your organization of your work. So as long as you're organized, we're good. Okay, I haven't dealt with that 3 feet per second. That's this rate of change. The base of the ladder is moving away from the base of the house. So what equals 3? Translate that into math. dB over dt, and that's 3, and it's going to be a positive 3 because although away makes me think negative, B is getting bigger. B is increasing. So dB over dt has to be positive. And then my equation again is a squared plus b squared equals c squared. Okay, what's my next step? Derive the equation with respect to t. And we've already done this once, so I'm going to go through this part a little bit faster. And you're going to get really good at deriving Pythagorean theorem. It works out the same way each time. And likewise, I'm going to just cross off the 2's each time. It makes it a little easier. Not a lot, but a little bit. Okay, once you derive, now we're ready to plug in. A was 12. dA over dt, that's what I'm looking for. B was 5. dB over dt, that's what they gave us is 3. C was 13, and they don't give us dC over dt. So what do we think? Why? The ladder is not getting longer or shorter. This is not an extendable ladder. It could be, but it's not. And we're just going to be thankful for that. Okay. Solve for dA over dt. Solve feature, algebra, however you want to do it. I'm going to go ahead and just give this answer. And that would be in feet per second. And we get a negative answer, which we said we would. So that makes sense. If I got a positive answer, you'd be like, hey, what happened? Okay, we're going to end today with this part B. We won't get to the part C yet. Part B says determine the rate at which the area is changing. What are they asking us to find now? Derivative of area, and I'm going to use big A for area. The when, the picture, the given, everything's the same. But if I'm using area of a triangle, I need to use that equation. So what would the equation of area of a triangle be? 1/2 base times height. Now, I didn't use h for height, I used a. So what I'm going to do is erase the little h here, and I'm going to write an a. You could leave it as h and change it up here to h. It doesn't really matter. Okay, again, you can use whatever letter you want. Okay, so when I rewrite this, I am going to actually put parentheses around the two pieces because I need to use product rule. The left side ends up just being dA over dt. On the right side, I need to use product rule. I'm multiplying two variables. So derivative of 1/2 a is going to be 1/2 dA over dt. That's the first part. Times just b. Plus just 1/2 a times derivative of b, which would be 1 dB over dt. So this is kind of more like what we did yesterday, but we didn't have to do product rule yesterday. Okay, I'm going to kind of encroach in the next space. So dA over dt, that's what we just found in part A. So that's going to be negative 1.25. B is 5. 1/2 a, that'd be 1/2 times 12. And then dB over dt, that again was given as 3. So you'd plug all that in, and I know I'm rushing through this, but that's just calculator work. You'd get 14.875. And since this is the change of area, what should my units be? For area, I would use feet squared per second. So at the moment when all this is happening, the area is getting bigger because that's a positive rate. So